Okay, so in the previous week, when we did Chapter 4, Section 3, we figured out how to write functions from situations, from stories. Oh, and I'm sorry, I got ahead of myself. Welcome to this video. We're doing Chapter 5, Section 1, Identifying Linear Functions. Page 300, we're going to do problems 13 and 14. Okay, so now, going back to what I was saying. In this video, in this problem 13 in this video, we're given a situation and we're even given the function. What they want us to do is they want us to graph the function. So we're going to draw a graph and we're going to sketch it. We're going to see what that's going to look like, and then we'll talk a little bit about the domain and the range. I'm not too worried about the domain and range right now. That's a very complicated idea that we'll be throwing around with lots of problems. So it's something you're going to pick up as we go. Okay? So we need to figure out how to graph this. But first, let's talk about what's actually happening. So a train is traveling at a constant speed of 75 miles per hour. It's pretty fast, right? So after 1 hour, it's traveled 75 miles. So wait, let's organize that information. I'm going to make a table. So, all right. 1 hour, I need some space here because I got to figure out what these things actually mean. So 1 hour, it goes 75 miles. 2 hours, 75 plus another 75 is going to be 150 miles. 3 hours, add another 75, I'm going to go 225 miles. 4 hours, it's going to go 300 miles. And we'll do one more. 5 hours, it's going to go 375 miles. Now notice that I just kept adding 75. But what I really did was I multiplied each number up here by 75 to get this. Well, what do these numbers on the top represent? I said 1 hour, 2 hours, 3 hours. This is time measured in hours. What do these numbers represent? Well, I said 75 miles, 150 miles, 225 miles. This is distance, and I'm going to abbreviate because I don't have a lot of room. Actually, I do have room. Distance measured in miles. I'll put the miles below it. Okay, so now we kind of have an idea. I have an independent variable, which is time. I have my dependent variable, which is distance. And if I look at this function written as a algebraic, well, in function notation, looks like my time is x, where I probably would have wanted to use a t, but like I said, it's okay. And, whoops, I'm sorry, 75x. And it looks like my distance is whatever f of x is, which equals 75x. All right, so that's connecting everything. It's connecting the words, the table, and the function written as an expression, or if you want to call it an equation, that's fine. The only thing I don't have yet is the graph, which is the whole purpose of it. So all I'm going to do is I'm going to sketch my graph. Along the x-axis, x, I'm going to write time, using hours, not minutes or seconds or anything like that. And I'm going to go 1, 2, 3, 4, 5 hours. 1, 2, 3, 4, 5 hours. Now on my y-axis, my dependent variable, I'm going to write on the side distance, and that's measured in miles. Now, be smart, because if you start counting off 1, 2, 3, 4, 5, it's going to take you a long time before you get to 75, and even longer before you get to 375. So it's kind of like my x-axis has shrunk. I've compressed it. And I can actually write these numbers like this. So 1 hour goes 75 miles, 2 hours goes 150, 3 hours goes 225, 4 hours, graph paper would be so much better, but that's okay. 5 hours goes 375. Almost done. And again, graph paper looks, I'm going to use my ruler. We'll call it a rough sketch, okay? Graph paper would make this a little bit better. The next thing is this continuous or discrete? And the answer is it's going to be continuous, because both time and measuring distances neither one of them have a smallest measurement. So there's always a measurement in between it. So we can go ahead and draw a line between those points. And that's what the graph is going to look like. One more. A movie rental store charges $6 to be a member, plus $2.50 for each movie that you're going to rent. They give you the function f of x equals 2.5x plus 6, and that's going to give the cost of renting x movies. Okay? And x is 1 movie, 2 movies, 3 movies, 4 movies. Alright, so let's start like we did with the last problem. Let's make a table, except I'm going to change this around a little bit more. First, I'm going to figure out what my independent variable is. And that's going to be the number of movies, which we're going to call x. I would have called it maybe m for movies or n for number, but they want to use x, okay? X. The dependent variable is going to be the total cost. And we could say that that's y, but we're also using f of x. So we can say y or f of x. Let's make a table. 0 movies is going to cost you $6, because you got to pay the $6 membership fee. If you rent 1 movie, that's going to be the $6 plus $2.50, which is $8.50. If you rent 2 movies, 2 times $2.50 is $5. 5 plus 6 is going to be 11. If you rent 3 movies, $2.50 times 3, $2.50 plus $2.50 plus $2.50 is $7.50, plus $6 is going to be $13.50. And you know what? Since I'm using money, I should put the zeros in for those too. 4 movies is going to be $10 plus 6, which is $16. And we'll do one more. 5 movies is going to be $18.50. Now, to connect this with what we've talked about previously, how do I know this is a linear function? Because the movies are increasing by 1 on my table, and the cost is increasing by $2.50 each time. It's going up by $2.50. Alright, so I've identified the independent variable and the dependent variable. I made a table. My equation is f of x equals 250x plus 6. All I have to do now is graph it. So like I said last time, I'm going to start off with my x and y axes. I did not say this last time. Why am I only going to do this, what we call the first quadrant, because I don't have anything negative up here. This will be the number of movies rented, and this is going to be my total cost. So I can do 1 movie, 2 movies, 3 movies, 4 movies. I think I went up to 5. Yep, 5. And unlike last time, I got that plus 6, which is going to mess with it. I know that I can make marks here, and I'd like to put these numbers in, but then that means my graph is not all spaced out correctly. Okay, so what I'm going to do instead is I'm going to say $5, $10, $15, $20, and this will be $25. and I'm just going to approximate. All right, so one movie is going to cost $6. So here's 5. 6 is just a little bit higher. 2 movies is going to cost $8.50, which is, here, this be useful. So if I had graph paper, I'd have a line going over through the 10. So $2 is not quite up to 10. Or 2 movies, $8.50 is not quite up to 10. For my 3 movies, I have, excuse me just a second, I messed up. I caught that, I messed up. Hopefully you guys caught it too. Maybe you're screaming at your iPad. 0 movies cost $6. 1 movie cost $8.50. So I need to figure out a way to like hide those. I'm gonna grab a piece of paper or something. I don't have anything. I don't have any whiteout or anything like that. All right, so just accept the fact that I screwed up. Right? 2 movies is going to cost $11. So here's the 10. I'm going to go up a little bit. So that's going to look like that. 3 movies is going to be $13.50, which is about right here. 4 movies is going to be $16, which is about right here. See, I was just a little bit above the 15. I'm doing my best here. And 5 movies is going to be $18.50. All right. So, oops for those 2. Sorry, didn't mean to do that. Okay, so now the question is, last thing, is this continuous? And do I connect them all? Or is it discrete? And the answer is, it is discrete, because you can't have half of a movie. I mean, certainly you don't have to watch the whole thing, but they're not going to let you rent only half of a movie and pay less, okay? So that's not how it works. So we're going to leave it. We're not going to connect the dots. And I'll tell you what, I will get something here to cover that up. I'm just tearing off a piece of paper like this. See what I'm doing here? There you go. I'll tape that over that so that it doesn't look doesn't look the best, but I'll tape it over that so when I take the picture of it, it'll be okay. All right, that's it. Ask questions in the discussion. Good luck.